All right. So the first question that we're going to talk about is going to be find an equation of the tangent line to the curve at the given point. Okay? And so the equation that I'm going to give is y is equal to 2x to the third minus x squared plus 7. And the point that's going to be given is 219, something like this. So if we want to find the equation to the tangent line, what do I need to do? What do I need first? Anybody? That's right, we need a derivative, right? So I'll take the derivative of this, and so I'm going to get y prime is equal to 6x squared minus 2x, right? But I need the slope. And since I need the slope of this, I'm going to need to evaluate at the value for x that is 2, correct? So I'm going to evaluate at x equals 2. So my slope should be 6 times 2 squared minus 2 times 2, which is 24 minus 4, which gives me a slope of 20. Agreed? So that's my slope now. What we can do to go ahead and find our equation is we're going to use point slope form. So I'm going to go y minus 19 is equal to 20 times the quantity x minus 2. So I'm going to get y minus 19 is equal to 20x minus 40. So y is equal to 20x minus 21. And that is the equation of the tangent line. Are there any questions on this one?
Nope. It's pretty straightforward.
All right. Number 2. Number 2, I'm going to ask that you find the first and second derivative. Okay, and the function for this one would be something like f of x is equal to e to the x minus x to the fifth. So what do we think happens here? What would the first derivative be?
E to the x.
Okay, that's one of them. That's part of it.
Times 1.
No.
Minus 5x to the power of 4.
5x to the fourth, right? It's the both parts.
Oh.
Okay. The second derivative then yields again e to the x, but we're going to have a minus what?
20x to the third.
20x to the third. Is that clear? Is there anyone that needs me to demonstrate why that becomes 20x to the third? We're all okay? Straightforward. Okay. Cool. Okay, let's do another one. Same thing. We're going to again find the first derivative and the second derivative, and our function is going to be f of x is equal to x cubed plus 8 e to the x, And here I'll skip that line so we don't have a gap. Make sure that's clean. Do you guys want to try it before I do it?
All right.
All right, try it.
Would you have to do the product rule to the parentheses and e to the x?
So it's it is a product, so that means we do need to do the product rule. Now it depends. If you distribute, it ends up being a little bit different. I wouldn't. So it just depends on how you want to attack it. All right, so the first one, see if you guys got what I got. Did you get that?
Yes.
Any questions on how I got that? No? All right. Second derivative then, we already know the answer to this one, right? The derivative to this is the same as the derivative to this. So this whole thing is going to be the derivative for this guy, correct? So I don't have to do much thinking there. This first part, though, I do have to do the product rule. So I'm going to get 6x e to the x plus 3x squared e to the x plus 3x squared e to the x plus x cubed plus 8 e to the x. And then we can see that we can clean this up. Let me see.
Yes.
I'm trying to make sure I have it right. 3 e to 6x e to the x, 3x squared e to the x. 3x squared e to the x. Yeah, that looks right. So then this middle term is going to be added up. So I can clean that up and get 6x e to the x plus 6x squared e to the x plus x cubed plus 8 e to the x. And then we could pull out an e to the x if we want, right? And if we did that, what would we get? I'll do it in descending order. And that's the answer to the second derivative. Any questions on that one? If you do, please ask. I don't mind explaining it in detail.
Sorry. Can you explain the setup?
To which one?
The second one, please.
Okay, so here, I'll use color, okay? So, first I'll do this. This is the second one. So the answer to the second one is going to be this, correct? Okay. Within that one, though, I have a product. So what is the derivative of 3 x squared. Isn't that 6x? So then the second piece stays the same, correct? In the second part of that in the product rule, the first one stays the same, correct? And then the derivative of e to the x is e to the x. Does that make sense? Okay. Now, the second part is the derivative of this, correct? But isn't that the original problem? So isn't this the derivative to this? So then I just wrote that again right there. Does that make sense? Okay, cool. And then all I did for the rest of it was algebra, right? Distribution and all of that. Okay. So there's number 3.
Professor McHugh,
Yeah.
a question with the first derivative. Do we always have to factor out that x, or can we just leave the solution standard?
Are you saying,
correct?
like, could I left it here?
No, here, the first derivative. The answer.
Here?
You know, they have an easy x. Can we factor out that easy x?
Well, you could have, but then you would have had another product.
Oh, I see.
So, like, you know what I mean?
Yeah.
I mean, it would have factored it out, which maybe would have made it cleaner, but I typically just leave it that way. And then, yeah, I don't know. I mean, you could have factored out e to the x. It's not that big a deal.
All right, sounds good.
It's probably better math, but sometimes we're lazy, right?
Yeah.
All right, here's number 4. Again, we're going to find the first and second derivative. And here. I want to give you guys a chance to try this. Nothing like being able to struggle, right? So give that a shot. You guys want me to try? Or are you still working? Do we agree?
Yeah.
Right? Because it's, just so that we have it, it's f over g, that derivative, is going to be f prime times g minus f times g prime over g squared. Agreed? All right. It's the second derivative that's a bit consuming, correct? So let's try to do the second derivative. I'll do it right here. So the derivative at the top is going to give me a negative 2x times x squared minus 7 squared minus, in fact, I'll make it positive, x squared plus 7 times 2x squared minus 7 times 2x all over x squared minus 7 to the 4th. Do we agree? I'm going to clean it up in a second, but do we agree?
Yes.
We okay?
Okay.
Well, I can see there's an x minus 7 here and an x minus 7 here that I can factor out.
Isn't the plus supposed to be a minus?
No.
Oh.
It's a plus. See how here this is minus and minus?
Yeah.
I factored out the negative and made it x squared plus with a negative in front. So minus and negative become a
positive.
Does that make sense?
Yeah.
Okay, cool. So I'm going to factor out a x squared minus 7. Plus 28, I believe, is 42x. We okay?
I have a question.
Sure, please.
Did you drop the negative on all of the x squared minus 7?
We're here?
On all of them, because isn't it supposed to be a negative x squared minus 7?
So the top one is a negative x squared minus 7, but the bottom one is x squared minus 7. So you need to know which one you're talking about. Does that make sense?
Yeah.
So here, another way you can look at it is I did it like this. So when dealing with the numerator, right, the derivative of this is going to be 2x, correct?
Yeah.
So 2x and a negative is going to give me that negative 2x. With the denominator, Now that negative, this is supposed to be a minus, right? But that negative makes it become a plus. That stays put. And then when I take the derivative of this, power rule, the 2 comes out front. Then the parentheses, and then what's inside by the chain rule has to have a derivative, and that's the 2x.
Oh, okay. Thank you.
Does that make sense?
Yeah.
Okay. Yes, this lecture is being recorded, Daniel.
Cool.
Okay. May I continue, or does anyone have any questions about the process on this problem?
Nope, I'm good.
We're good? Okay. So now I believe we're on number, what was that? That was number 4. So let's go on to number 5. Okay. So for this one, we have f of x is equal to x squared sine of x. And I'd like you to find me the derivative of this. So basically you can tell this whole test is going to be about taking the derivative, right? So I try this problem. All right, so the first derivative of this, it's obviously the product rule, right?
Correct.
So the derivative of the green goes first, and the derivative of the green should be
Right.
2x. We leave sine of x alone, and then it's a plus, and then it's x squared, and the derivative of sine x is
Cosine x.
cosine x. And there it is. That's our solution. Very straightforward, right?
Correct.
Unless you don't have these things down. So that may happen. And I'll write the rule so that you have it. Okay. I think my test is going to have about 15 questions on it, so it shouldn't be too bad, but it's enough to where...
I had a question.
Yes.
It's nothing related to the problem. I'm pretty, like, I know how to do all the taking derivatives and everything, but what is exactly, like, taking a derivative of a number mean?
So when you take the derivative of something, it's to find the slope of the function in general, right? So in this...
Oh, yeah. Usually, yeah, I remember.
Okay. Okay. I was about to go into a speech, just like...
Yeah, I remember to find the slope of it. And to find, okay.
Yeah, that's right. Okay. That's funny. You're like, no, don't. I heard it before. I got it.
No, not like that. I just instantly remembered once you said the slope, to find the slope. I was like, oh, yep, I remember.
Yeah. No worries. Okay. So
What day is the test gonna be?
what's that?
What day is the test? Is it Tuesday? Oh, sorry, I came a little late.
Oh, got you. Man, just watch the recording again, and you'll get the answer. I'm just kidding. It's probably gonna be next Thursday. It's
Okay.
gonna be next Thursday.
Okay, cool.
Yeah.
Thank you.
Yep. No worries, Daniel. Okay. So for this one, what I want to do is, again, I want to find the equation of a tangent line. to this curve that I'm about to give you. And here's the curve. It's y is equal to 5e to the x cosine of x, and I'm going to give you the point 0, 5. Why don't you guys try it, and then I'll do it for you. Jose, very close. So check this out. When I take the derivative, it's going to be 5e to the x cosine of x plus 5e to the x minus sine of x, correct? So when I clean that up, that's going to be 5e to the x cosine of x minus 5e to the x sine of x, right? But where are we evaluating it?
At 0.
Correct. So x is going to be equal to 0. So I'm going to get 5e to the 0 cosine of 0 minus 5e to the 0 sine of 0. But sine of 0 is what?
0.
Yeah. So I'm going to get 5 times 1 times 1 minus 5 times 1 times 0, which is going to give me 5. So 5 is my slope. Right? And they gave me the point 0, 5. So that's already in intercept form. So y is equal to 5x plus 5 is the tangent line. We okay? Is it easier when I do it? Oh, yeah. Yeah. It's a constant, right? Remember how I told you a constant times a variable? When I take the derivative, it's the constant. So like if I had something like this, right, and I took the derivative, I get the constant times the derivative of that. So it'd be 2cx would be the derivative of that. Does that make sense? Okay. Yeah, that's important. The constant doesn't get dropped. No, my pleasure. All right, let's see. I want to give you the next one, and I want you guys to try it. Are we on number? Okay, we're on 7. So let's find the derivative, and the function is 3x to the 6th plus 8x to the 3rd to the 4th power. So let's see what you guys come up with. Did you get it, Daniel? You got it? All right.
Still working.
Oh, I thought you were just looking. Okay.
This one is just a product rule, right? It's nothing to it.
Product rule?
I mean, no, the
Chain
the
rule.
power rule, like.
Well, it's the chain rule. It's got the power rule in it. Yeah. So look, if I go f prime of x, I have to do the outer part first, correct? So the outer part's the 4. So I'm going to get 4, and then that drops 1, correct? But the inside stays the same. But now I need to multiply by the derivative of what's on the inside. So the derivative of what's on the inside is going to be 18x to the 5th plus 24x to the 2nd. Do you agree with that?
Yeah.
Okay. And I mean, we could clean this up if we wanted to, but it's like, oh, do we really want to clean it up?
Yeah.
I mean, we can, but yeah, we get it from here, right? The algebra to clean this up, that's just algebra.
This one felt too easy to be true, so I was like, am I doing it wrong?
Well, the one thing that may happen on WebAssign is they may ask you to clean it up. So, can you clean it up? I'll give you what the clean answer is, and then see if you guys can do that on your own. But that should be, you should be able to see that, right?
Yeah.
But it isn't bad. I mean, chapter 3's test really is, it's about knowing techniques, but it really is very straightforward. The one thing about chapter 3, though, that I will stress to you guys is when you go and take Calc 2, if you don't have your derivatives truly down, you're going to have a lot of problems in chapter 7. Chapter 7 to me is the hardest chapter in Calc 2 because it's integration with derivatives in them. So there's these techniques of derivatives where you're doing a bunch of stuff, and if you don't know your derivatives, you're going to be in a little bit of trouble. Okay? So chapter 3 is huge. All right. Here's the next one. Again, find the first and the second derivative, and let's say I gave you y was equal to, I can write it in terms of function notation, that's fine. E5 e to the x. Did you guys get the first derivative? All right, tell me what you got.
E5 to the e of x.
You said e5 to the e of x.
And then the derivative of the inner function,
Okay, and what was that?
5ex.
Okay, so then times 5 e to the x, correct?
Correct.
Okay, now something for you to be able to know and clean this up that's important It'll make it easier when you take the second derivative here. I'm going to get 5e to the x plus 5e to the x. That's just cleaning it up, right? Because they have the same base.
Oh, yeah.
So since they have the same base, I can clean them up that way. Is there anyone that doesn't see what I'm talking about?
I don't see it. Can you clarify, please?
Yeah. So, okay. So you see, do you agree with this, correct?
Yeah.
Okay. So remember from rules, if I had something like, all right, x to the second times x to the third, what do? Doesn't that become
Add the
x
exponent.
to the 2 plus 3?
Yeah.
Okay. So here we have a 5 in front, right? But the base is e. And the two exponents that we have are 5e to the x and x. So you could have written it this way. 5e to the x plus x, which is the same as what I wrote it. I just wrote x first. Because you see the exponent here and the exponent here for the same base. So just like we did this, we add the exponents.
Can you clarify on how you got the first derivative again, please?
How I got this?
Yeah, that's that.
Okay, so what's the derivative of anything e?
The exponent of it.
It's
E to whatever it is.
Yeah, so e to whatever it is. So this guy, when I take the derivative of this, is this. Agreed?
Yeah.
But then
And
this
you gotta take.
but then this is the inner, so what's the derivative of this? It's 5
Okay, I
times e
see
to
it.
the x.
5 e to the x.
Yeah. You with me?
Yeah.
Alright. Cool. Alright, second derivative. Did anyone get that yet, or are you still working?
Oh.
Hieroglyphics. That's pretty good. I hate hieroglyphics. I don't know. Buffalo. Solving math problems, hieroglyphics. That's pretty good. All right, so for this one, the 5 is there. That's not going to be differentiated. But then the e is going to leave itself as e with the exponent, correct? But now I have to take the derivative of the exponent piece. So what is the derivative of x? Isn't that 1?
1.
And then 5e to the x is just simply going to be 5e to the x, correct?
Right.
And that's the second derivative.
This problems look scary, but they're like easy, but then you're like, do you really got it?
Oh, they're easy for sure. Most of these problems are easy when you see someone doing it. It's when it's like it's on you and you're like, oh, it's on me. It gets a little bit tricky, but no, none of these problems am I going to try to make to like stress you guys out or hurt you. They're going to be manageable, but if you don't know what to do, you can get lost very easily, right? So make sure you're careful and you're well prepared for the exam. All right. I think we're on 9, right? All right. So look at this. I want to find the derivative of this. Go ahead and try to find the derivative to this. Still easy? You got it? All right, let's play. So because this problem can't be solved for y, we see that we have to do this how?
Implicit.
Implicitly.
Different.
right? And we could pull out a 2 if we wanted, but I don't care. Agreed? Here, just in case people pulled out the x, pulled out the 2. Same thing.
Professor, in the middle expression of the 4xy, we have to use product rule. That part, correct?
Here?
Where it's x squared minus 4xy.
Yeah, this is this is
right above it. Right above it.
Yeah, because this right here is a product.
Okay, cool.
Yeah. Because they're both with respect to x, we need to treat them both as variables that are differentiable, and so it's a product.
In the second step, why did the
I have a
4?
question.
Oh.
Oh, sorry. Did I cut someone off?
Yeah, Daniel.
Yeah, I'll be quick. Why is the 4y before the 4x just in the second step when you break it down? Like when you
Here, I took the derivative of the first. Right? It's f and g. So I took the derivative of f first, which is 1, times the y. And then over here it's 4x, and then the derivative of the y is the dy dx.
okay.
Does that make sense?
Yeah, I think so.
Okay. All right. Someone else had a question.
Yeah, I had a question, and my internet connection's really bad right now, so I couldn't even hear what Daniel asked. So I hope I'm not asking the same thing. But I was asking why the derivative, the dy over dx, is over 2 parts, and then you got rid of it.
Oh, I didn't get rid of it. So see here and here. This one is because of this product rule, correct?
Sure, I can't see what like you're doing on the whiteboard, so
Oh,
I'm just gonna say
you don't see a dot, a red dot?
no. I'll leave and come back because something's going on.
Oh, okay. When you get back, let me know, and then I'll answer your question. That's a bummer. That's the thing. This is such a bummer for you guys. Is there times that I sound like a robot?
I don't know, like right now everything is slowed down. I thought it probably is me, yeah.
I thought it was me too. I thought my internet connection was just bad.
Oh, then,
I've been hearing everything pretty clearly.
Yeah. Yeah, I try to have, like I pay for stupid internet, so it's like really solid for you guys, because, you know, if my internet was terrible, how would this work for you guys? But it could be my side too, so we'll see. Part of the thing is Zoom also gets bogged down. So it could be even that it's none of us and it's Zoom, right? So if you don't hear me, speak up so I can go over it again, okay? Please. I want you guys to be able to understand this. All right. Let me do number 10, and then I can come back to 9. I'm not sure who it was that asked the question. It's a bummer. But I can come back to that. Okay, let's do this one. All right, try this one. Oh, it was red. Okay, cool. Thanks, Sarah. Appreciate that. No, you're funny. It's all good, dude. Do you want me to answer your question while people are working on this problem?
Yes, please.
All right, so what was, you were trying to find out why there was two dy dx's, correct?
Correct.
Okay, so I'll do this. So here, there should have been a 1, right?
Yes.
If I take the derivative of it, then the green stays here, and then the red doesn't change, and here the red takes its derivative, right? Because it's the product rule. So that's what gives me my dy dx there, right?
Oh, okay.
Right, by the product rule, because the product rule, remember, it goes like this. It's f times g prime is equal to f prime times g plus f times g prime.
Mm-hmm.
Okay, so that's how I got this section here. Now, do you see that red dot?
Yeah.
Okay, cool. Now, for this one, it's from here. I do the power rule first, so I get 2y. And then by chain, I have to take the derivative of the y. And the y, since it's respect to x, it has to be a dy dx. Right?
Yes.
Okay, now that I have dy dx and dy dx, I can factor out a dy dx. So I'm going to get 2y minus 4x. 2y minus 4x.
Oh, I get it.
You see it?
I get it.
All right.
I get it.
Yeah. Good. And then this guy just got moved over to the other side, changed
Yeah.
signs. And this one got moved and changed signs.
I see. Okay, cool.
All right, cool.
Awesome. Thank you.
Yeah, my pleasure.
Professor, so the 4 was like moved to the other side?
Yeah, it's just a constant, right? The 4 right here that you're talking about, or the 4y, these two got moved to the other side because they didn't have dy dx.
Oh no, I get the part, but at the very start, the 4, you know how you did equal to 0?
Oh, here?
Yeah,
Okay, what's the derivative of constant?
0.
0.
Oh wait.
So that's why that became a 0.
Okay.
This 4 is there because of this product. This 4 goes away when I take the derivative.
Okay, and then you use the formula up there. Okay,
Yeah.
I get it.
Okay. All of a sudden, the derivatives started getting a little bit more complicated, huh? Yeah. Now, honest question, do you guys feel like you're supported by me through all of this?
I do feel like you answered the questions and the work of showing us how you get the steps, and I think that's pretty helpful.
I want to make sure, because I don't want you guys to feel like you're like lonely out there, especially with this stuff. So, yeah, I want you to feel like, all right, I got your back with this math stuff. You're not alone, you know. I've heard from some students that they're like, we just get like these videos put up and then there's PowerPoints and that's it. And I'm like, I don't want to do that to you. So I wanted to make sure you guys are feeling like you're supported. So that's good. Okay. Do you guys want me to show this one? Are you ready for me to show it?
Yes.
Yes.
Okay, so here we go. So in this first piece, we're going to have to do the outside function, which is the cosine, right? We're going to have to take the derivative of that. And so we know that that's going to be a negative sine of xy, right? Ooh, that's terrible. But then we need to take the derivative of the xy piece. And so again, that's a product. And since it's a product, it's going to be the derivative of the x, which is 1. So I'm going to get 1 times y plus x times dy dx. And the dy dx is because it's the derivative of the y, and we don't know what that is. Equals, now we're going to the other side, the derivative of the 1 is 0. Plus, now we're doing the derivative of the sine, and the derivative of sine is cosine of y. But then we need to do the inside piece of that, which is the derivative of y, which gives us dy dx. Does that make sense? I can break it down further if you need me to. Okay. So when I took the outside piece, that was this, right? The derivative of cosine is this. This piece, since it's a product, I'm going to take the derivative of the x first. That gives me the 1 times the y. Then plus the first times the derivative of the second, which is the y, and that has to be implicitly done as dy dx, correct? Now once we have that side, we're going to be over here on the other side of the equal. Derivative of a constant is 0. The derivative of sine is cosine, and now we have to take the derivative of the inside piece. Since that's a y, it again will be implicitly done. Okay, now we have to distribute things, and so what I'm going to get is a negative y sine of xy minus x sine of xy dy dx is equal to cosine of y dy dx. Okay? But now we want to put the dy dx terms together. Correct?
Yes.
So if I want to put them together, I'm going to go negative y sine xy is equal to, I'll go cosine of y plus x sine of xy, all of that by factoring out dy dx. Yes?
Correct.
So then dy dx is equal to negative y sine of xy over cosine of y plus x sine of xy. And that's our answer. Cool?
Got it.
Any questions on the process for this problem? No, I'm that thorough. All right. Are you guys done copying it so I can go on to the next one then? Yeah?
I'm good.
Okay.
Give me a second.
Okay, no problem.
Okay, I'm good.
All right, cool. All right, number 11. So let's find the derivative, yay, of sine of 7 ln of x. Close. You guys ready for me?
Yes.
All right. So the outside derivative first, correct? So we have to
Right.
have cosine of 7 ln of x, and then we need to take the derivative of the inside. So the derivative inside is going to be 7 over x. So that yield 7 cosine 7 ln of x over x. Any questions on this?
No.
Just so I can clarify, just in case someone isn't sure, everyone gets how I got the cosine.
Yes.
It's the inside part that gets people. The 7 stays out because it's just a constant. What is the derivative of ln of x?
1 over
It's
x.
1 over x. So 7 times 1 over x yields that 7 over x.
I mean, I wrote it like that, and I got the same answer too.
Oh, good. Good. Does that clarify it for everyone? Okay. All right, cool. Here is number 12. We again want to find the tangent line for y is equal to ln of x squared minus 9x plus 1 at the given point 9, 0. You guys ready for me?
Mhm.
All right. Agreed?
Great.
And the point that was given to us was 9 comma 0. Is that right?
Yes.
9 comma 0. Okay, so then we'll go y minus 0 is equal to 9 times x minus 9. So y is equal to 9x minus 81. And that is our tangent line. All right, that's good. Coming along.
Could you go back up to like where you started the problem? So on just the second step, because I got those two of like the 1 over, but I also had an extra natural log. Did I like because this is the product rule, right? And so it's like
It's not the product rule. Where's the
it's
product?
not? Wait, so what rule was it?
It's natural log. There's no product here. It's the natural log of something, right? So if I gave you, let's go to the most basic form. If I gave you ln of x, right? When we take the derivative of that, what do I get?
That's just the 1 over x, right?
It's 1 over x, and then really it's times x prime, right? And x prime would have given us 1. Agreed?
Mm-hmm.
So 1 over x, that's this, and then the derivative of the inside, which is 2x minus 9.
Okay.
Does that help?
Yeah.
Yeah. No, so many times we see parentheses and we're like, oh, hell yeah, we're going to multiply, right? It can happen to any of us. I mean, look, I've done it. You know, I've seen professors that are way smarter than me do it. You know, if we're careless for a second, it can eat us up. So be very careful, okay?
Okay.
We're in the 7th week, huh? 6th week, huh?
I think so, yeah.
Gosh. Hey, when we're back on campus, if you guys see me, just give me a high five. Like,
Okay.
even some of you who I've never seen because you always just have your names up, just be like, high five, Montiel. I'll be like, oh, that was my student. I'll know because you gave me a high five. It's crazy. I miss being in the classroom. Although I gotta tell you, no joke, you guys are a really cool group. Oh, dang. It's cool that you guys actually participate in class. Some of my other classes, it's like they don't ask a question. I'm like, All right. Just talking to myself. Really a lot of fun. It's sad, actually. All right. Now, let's get into some related rates. So this is number, it should be, is it 11? No, 12, 13.
13.
13. So here we go. So at noon, ship A is 180 kilometers west of ship B. Okay. Ship A is sailing east at 40 kilometers per hour. And ship B is sailing north at 30 kilometers per hour. How fast is the distance between the ships changing at 4 p.m.? Now, do you guys want to try this, or do you want me to explain it and do it?
Explain it, please.
Okay, no worries. Okay, so the first thing that we need to find out is how much time gap is going to happen when we're trying to find our rate of change.
4 hours.
It's going to be 4 hours, so that's important because that's going to tell us how much distance is covered, okay? So if I draw this picture legitimately like it's going to look, we'll call this ship A, we'll call this ship B, correct?
Mhm.
And what I know is there's a gap between them of how far?
180 kilometers.
180 kilometers, right? Ship A is 180 kilometers from ship B, right? To start. But what do we know about ship A? Which way is it going?
East.
East.
So that means this ship is going in this direction, correct?
Uh-huh.
Right?
Correct.
So the distance from ship A to ship B is actually going to be getting what? If ship B didn't move, it'd be decreasing. Well, by how much?
Huh?
By whatever the distance that was covered would be, right?
Yeah.
So wouldn't that be 180 minus x here?
Oh.
Right?
Yeah.
Okay. Ship B, though, is going this way. Right? Oh, one thing I should state. What do I know about then dx dt here? I'm drawing a picture right in the... Isn't dx dt here going to be what?
40 kilometers.
40. Cool. This is going to be in terms of dy dt. And what's that going to be?
30.
30. Very good. So we can create a triangle for this thing. All right, you guys ready for my triangle? My triangle is going to look like this. Boom, boom, boom. And it's going to be a right triangle because one's going straight north Although my line doesn't seem straight. Right? Now, I'm going to draw it so you guys can see everything, so it makes sense. So how many hours had passed when we wanted to find our time?
4 hours?
4 hours, right? We need to find this, and we need to know what dz dt is. That's what the actual problem is looking for, right? We'll find dz dt. Okay, so 4 hours. So in 4 hours, how much did ship B travel?
120 kilometers?
So this is going to be 120 kilometers. Does everyone agree with that?
Thank you.
Yes?
Yes.
Okay. What is this going to be? How much did the ship A travel east?
160.
160. But to be in line with B, it was 180 away. So this gap now is how far?
80?
Isn't it 20?
Yeah, 20.
Does everyone understand how I got that 20?
Oh, 180 minus x and then
That's
x
right.
in there.
That's right. So it's the 180 minus x. Is everyone okay with that?
Mhm.
All right. Now, I'm good, but I'm not that good. So I'm going to go 20 squared. Oops. Stupid computer. 20 squared plus 120 squared. And then rooted. I'm going to get, actually, do you guys want me to do it rooted? Actually, I'll just do specifically what it is so we have exact numbers. 14,800. Okay? Now, since we're trying to find the rate of change between the two boats, we need to do what kind of equation?
So the Pythagorean.
The Pythagorean theorem, right? So now we're going to have x squared plus y squared is equal to z squared. So when we do the implicit here, I'm going to get 2x dx dt plus 2y dy dt is equal to 2z dz dt. And we know almost everything now, right?
Mhm.
I guess I could have done it that way. That's okay, doesn't matter. What is my x? For me, it's going to be 20. The rate of change was what? It was 40. My y is 120. And this was 30. And then we said z was square root of 14,800. Let's go get our dz dt. So let me get some numbers for you. So 3,600 plus 800 divided by You know what? I got the wrong sign. You want to know why I got the wrong sign?
The direction?
No, it's not the direction. This 20 should be it should be a negative 20, not a positive 20. This guy, which makes this a negative. I'll explain it to you guys just real quick so you guys can see it. Because the gap is how far the ship went, x, minus 180.
Oh,
Right? Because we didn't get all the way to the 0, so we're still on the negative side, if you will.
oh.
Does that make sense?
Yeah.
And so then that gives me my dz dt of 23.0159 kilometers per hour.
How in the world did you figure that out using your calculator that you got that wrong?
Oh, because, so check this out. This will make sense. The rationale for it. So when you look at the problem, right? My triangle here. If I look at it like this, okay, and I think of this as the origin. As I'm coming this way, do I ever get back to a positive?
No.
No. So my gap was a gap of 20. Because I'm heading from west to east, I had a gap of 20 there. So that's why that had to be the negative.
Oh, okay.
Does that make sense if you think of it in terms of numericals?
Oh, okay, I get it.
Yeah, because we're talking about direction. And so direction, before we get to where the horizontal and vertical lines cross, to the left of the vertical has to be negative, right?
Yeah.
One way we could have done it too is, instead of thinking of this like this, I could have gone my x minus 180.
Yeah. Okay.
And instead, where I messed up is I went 180 minus x.
Oh, I see.
It should be x minus 180?
Yeah, that's what I would say, because we're shrinking the distance that we're getting to get back. Does that make sense?
Okay. Yeah. X minus.
Like, this is like ruler postulate, like absolute value, but when I'm going to treat it to be able to solve it, I need to be able to think of it this way.
Oh, I see.
So, my bad. Crazy. Any questions on this one? Did I explain that okay for you guys?
Yeah, pretty.
All right. All right, let's do this last one. And this is one I think that you all should be able to do. I think this is number 14, right?
Mm-hmm.
All right. A ladder is 10 feet long and rests against a vertical wall. And the vertical wall piece is very important, because if it wasn't a vertical wall, guess what happens? We end up with a non-right triangle. So we need it to be a vertical wall. Okay?
Mm-hmm.
If the bottom of the ladder slides away from the wall, at a rate of 0.8 feet per second, how fast is the angle's rate of change when the bottom of the ladder is 6 feet from the wall. We okay? So now this problem's actually, it's pretty crazy. It's asking us to attack to get the angle, okay? So if we're going to look for the angle, it's a little bit different, right? All right, so we need to know how to draw this. So are you guys ready for my drawing? Did you guys write this down?
Mm-hmm.
Okay. So here's my vertical wall. Here's this ladder. And so we have a right angle. And we know that the ladder is 10 feet, correct? All right. What else do we know?
The distance from the bottom to the vertical wall is 6 feet.
So we know that this will eventually, when we're addressing it, will be 6 feet, correct? The angle that they're talking about is this angle. And really, I think I copied the problem wrong. I want to write it down so you guys have it exact. Yeah. How fast is the angle? Yeah, let me write this down so you guys have it exact. Because if the way I wrote it is fine, but it's better to have the words exact. How fast is the angle between the ladder and the ground changing when the bottom of the ladder is 6 feet from the wall. That makes it clearer, right? I just want to have it completely clear for you guys so that you guys see that. Okay, so if we're trying to find the rate of change of the angle, right? We need to have with the information that we've got, this is going to be 6, but right now we know it to be as x, right? We know this to be the height is y, right? Agreed?
Mm-hmm.
So if we only want to address this in terms of the angle with known pieces, and what we know this, right? So we want to incorporate this into finding this angle. So we don't know this. We know it's eventually going to be 6 when we do it, But in order to come up with a function, we want to be able to reference the angle with respect to this and the known hypotenuse. Understood? So what can I use that's going to use the angle, that's going to use the x and the 10? Well, this is adjacent, this is hypotenuse. So what uses adjacent and hypotenuse?
The cosine.
Cosine. So we're going to say, all right, cosine theta is going to be equal to x over 10. Okay? Because we're trying to find out what the derivative is in the general. Agreed?
Mm-hmm.
Okay. So then when I go to take the derivative of this, don't I get negative sine of theta is going to be equal to 1/10? Right?
Yes.
But we also need to take the derivative of x implicitly, which is going to give us dx dt. Ooh, and I didn't do the implicit on the other side, silly me. d theta dt dx dt, right? Because whenever we're doing a rate of change and we're talking about time, we must do it implicitly, correct? Right? Okay,
Correct.
what are we looking for in this problem? From our problem, what we're looking for is we're looking for the rate of change of the angle. Agreed?
Mm-hmm.
Okay, now, how fast was the thing sliding away from the bottom? That was given to us. Do you guys remember?
8 feet per second.
0.8 feet per second, correct? So our dx dt at that 6 feet was 0.8 feet per second. So we're going to get negative sine theta d theta dt is equal to 1/10 times, and can I just call it hold on, let me see, is that right? If the bottom of the ladder slides away from the wall at a rate of 0.8 feet per second, yeah, 0.8 feet per second. Can I call it 4/5 just to keep it as a fraction?
Yeah.
Are you guys okay with that? Okay. Now we want to find and see if we can get sine of t. So if we have 6 and 10, can we find out what y is?
Yeah.
What is y?
Six?
It should be 8.
Okay.
Does everyone see how this is 8? Right? Pythagorean theorem. Okay, I'm going to move the negative to the other side. So I'll have sine theta d theta dt is equal to a negative, what is that going to reduce to? 2/25. Agreed? Okay, now what is sine theta of the triangle? It's opposite over hypotenuse, correct? So opposite over hypotenuse is going to be 8/10. And then d theta dt should be the reciprocal of that. No, I should have reduced it. Oh well. what's that going to be? 5 will cancel. That will become a 2, that will become a 5, that will become a 1, that will become a 4, and I get a negative. Oh, I can even reduce more. Is that a negative 1/5? 1/10. Right? And since we're dealing in angles, this is radians per second. So you can see when dealing with the angles, it's they're a little bit tricky, right? Any questions on this one?
Professor, at the top, when we're going cosine theta equals x over 10, and then we take that derivative minus sine theta.
Yeah.
1 over 10.
I'm sorry, you broke up.
Oh, I'm sorry.
Say that again.
So to get from x over 10, 1 over 10, d of x, d of t, use the quotient rule?
To get from here to here?
Correct, huh?
I used implicit. So what is the derivative of x?
1.
It's 1, right?
Mm-hmm.
But then I'm going to get the 1/10. Oh, actually, what am I talking about? I just factored out the 1/10. The derivative of x is dx dt. Silly me. Mm-hmm. The way you can think of it is like this. It's 1/10 times x. So you get the 1/10. And then what's the derivative of x? It's dx dt. Right? Because it's an implicit differentiation with respect to time. And then on the other side, we're doing the implicit differentiation of theta with respect to time.
Okay. All right. Thank you.
Yeah. I mean, that is the crux to this problem. Okay? And that's, if you haven't done 3-9, that's where the practice is going to come from. Okay? That's part of the reason why I want to have the test next Thursday, is because on Tuesday, I want to be able to answer all the questions that you guys have on all the implicit and related rate stuff. Okay? Does this help?
The word problems, yeah. I just have to practice.
Okay, cool. Do you have homework questions that you'd like me to go over with you all? You're okay? Because this is pretty much, I will pick, it will be problems similar to these 14 that will be on your test, okay? So if you study this, you should be pretty good for the exam. Obviously, you can see it kind of, it starts off easy and then it tears up, right? But it should be something that is doable. Okay, do you have any questions?
On the exam, will there be any natural log problems where we have to derive things implicitly?
Oh, there could be. Didn't I do one that had a natural log and did implicit? Let me check.
I think number 12, but we didn't use implicit differentiation.
I mean, there could be, right? If I gave you something that was like ln of x, y, that would be a implicit problem.
Okay.
It would be similar to 10, right?
Yeah.
Yeah. It's not. That's,
all right. Cool.
It's nothing that's too crazy. All right.
Got it.
Anything else? Do you guys want me to? Here, let me stop recording. That way this thing doesn't get crazy.